Alright, so what I want to do in this video is to show you how to use Matlab to generate plots of some data. The data we're going to use for this video is in this file right here. It's called data.txt. This can be data that you've collected through an experiment or through a numerical simulation or whatnot. And you can see my data right here is arranged into 4 columns, 1, 2, 3, and 4. The first column you can see ranges from -40 all the way down to +40. And then, so that's going to be the independent variable in the plots. And then I have 3 other columns right here, just side by side by side. We're going to plot those with respect to the independent variable in the first column. You notice these columns are, in my case, are just separated by a couple spaces. In your case, you can separate them by commas if you want, or these spaces just like I have. So the next thing I want to point out before we do this plotting is that Matlab likes to organize quantities in terms of matrices. In fact, that's why they call it Matlab. This mat here is short for matrix. So let me just do an example here. I've got this matrix I've already sort of created. I call it M. So this M is a 4 by 3 matrix, right? It has 4 rows, 3 columns. And if you were to enter a matrix by hand, this is how you'd do it. You'd separate the columns by these commas and then separate the rows by the semicolons. And that sort of command right there would create exactly this matrix right here. In fact, you can say size M and it would tell you 4, 3 because this is a 4 by 3 matrix. If you say M, let's say I say, how about 2, 1. So put that in parentheses, M2, 1, what do you get? It spits out this 4.4. What does that mean? That means here's my matrix M, and I'm looking at the second row, first column. So here's second row, first column right there. It's 4.4, and it produces that one number. So let me bring back M again. So there's all of M. Now what I want you to show you is this. So if I say M, instead of saying 2, 1, let's say I say colon, 1. What does that produce? Oops, I was looking at it weird. I didn't do colon, 1. I did colon, 2. That's fine too. So that means I'm taking all the rows out of the second column. So notice that I picked out the second column right here. And that's what that does. So M colon, 2 will pick out the second column. M colon, 1. That's what I intended to do, would pull out the first column. That's what the first column was. And that's a way I can pull columns out of a matrix. All right, this is going to be important to us because now we're going to go and load that data file that we talked about just a little while ago. Now that data file was over here. Where are we? Data over here in my folder ME381, fall 16, homework 1, code, T-series, debug. So it's in some folder that I got to go access. So the way I access it is from up here, and I can actually go pull out this folder. I actually have this folder saved, which I can get to it that way. But you have to go into this little bar right here where you can actually get to the folder where you're interested in finding the data. And when you're there, you should see in this current folder, you should have that file. In my case, it's data.txt. So I'm going to load this thing. To do that, I just type load. And then the file name, data.txt, hit enter. And what that did was it loaded that file into memory. And it loaded it into a variable called data. Actually, not a variable, a matrix called data. So for example, if I say size data, it is an 8001 by 4 matrix. So it has 8001 rows, 4 columns. And remember that first column was the independent variable. I'm going to call that first column time, or T, and I'm going to say that is equal to data colon, 1. Remember that pulls out the first column. And if I hit that, ooh, look what that does. There's that T, and notice that it's ranging. Ooh, it looks like it's too big to show on one screen, but it ranges from -40 all the way up to +40. I just can't print it all on one thing. So there is the first column. The second column is my next dependent variable that I want to define. I'm just going to call that one S. That is data. I'm going to pull out the second column, so data colon, 2. And if I don't want the whole thing to display on the screen, I'm going to suppress the output by putting a semicolon, and boom, now it's in S. In fact, I can say size S just to make sure it's there. And so there it is. So 8,001 rows, 1 column this time, just because I only pulled out that 1 column from data. And I'll pull out the other ones too. I'll call the other one Y1. That's be data : 3. And Y2, I'm going to call that data : 4. So now I've got all my data. All right, so now that we have our data stored in Matlab, it's time to do the plotting. And plotting is actually quite simple. All I do is say plot. I'm going to say t on that variable t on the horizontal axis and s on the vertical axis. And boom, it creates a plot for me. Isn't that nice? Ta-da! Couldn't be easier. Now, let's say I want to display more than one curve on that set of axes. So what I'd do is I'd say plot. I can put multiple ones on here. So I got t horizontal axis, s on the vertical axis. The second plot would be t on the horizontal axis, y1 on the vertical axis. So now I'm plotting 2 things on the same axis, I think, I hope, I want. And there it is. Right, so the first one we did, it turned out to be blue, and then sort of by default it chose the next color as green. But there it is, and it's working quite nicely, I think. So now let's suppose I want to do some scaling of this plot. I don't like the axes that they chose. What if I want this thing to go from, say, in the horizontal direction from -10 to 10, so this little window right there, and in the vertical direction, this is too big. Let's go from -3 to 3. So one way to do this, at least by hand, is to click on this little, what is that, magnifying glass tool, and we can actually scale it by hand. But you can also do it inside the command window. You can do it explicitly and precisely. So the way you do it here is you say axis. And I always forget whether it's axis or axes because there are 2 different commands. One's called axis, the other one's called axes. But here, in this case, it's axis, and you just put in your plot range. So it's going to be -10 to 10 and -3 to 3 in the vertical direction. Now again, Matlab likes to deal with matrices, so this thing in Matlab is actually takes the form of a 1/4 matrix, which is why we have these little square brackets right there. But that's just the syntax, and once you get a hang of the syntax, it's really not too bad. So I clicked on that, and wow, that looks nice, doesn't it? Now when you're plotting, it's always good to label your axes. So let me say x label, and I'm going to call that time. That'll be my independent variable. And let's say y label, and there's 2 functions on there, so I'm going to just call this values. And if I want to rename that, I can later, and I'll show you how to do that. So now notice I have a time on the horizontal axis and values on the vertical axis. And now I want to make my plot look prettier. And pretty much anything you can do with your plot is something you can do on the command line by typing in things like x label and y label. Sometimes it's better to work things out through the graphical interface just so you can swap things in and out and check out how it looks. So the way you do that is you go to this plot window, and there's a button right here. I think this is the one. It says show plot tools in doc viewer. I think that's the one I want. So it's opening up those plot tools, and it created this thing. And I can click on various things and change them. For example, this blue curve right here. Notice that I click on it, it highlights it, and it tells me some information about it. And if I don't like something about it, I can change. So, for example, I tend to like my curves that I plot. I like a thicker line. Right now it's at a half. Let's make it 2. So notice that got thicker, right? And I can do the exact same thing with the green line if I just click on it. And there's the green line. Oh, I don't want to change its color. I want to change its thickness. There's its thickness. I kind of like that. And this is what I can do. I can change various things about the figure by clicking on things and changing it. So, for example, I could change the limits on the horizontal axis or the vertical axis. And I said I can change this label too. Maybe I wanted to capitalized, so values like so. Doing that, I changed it and it changed right up there. So you can mess with stuff this way. It's actually really kind of nice. Come to think of it, notice that I just have two curves plotted here. The S curve and this one I called Y1, but I had another curve that I wanted to plot, right? I called it Y2. Let me put that on there real quick. Now if I just say plot TY2, then it's going to erase all the stuff I have. So here's what I'm going to do. I'm going to say hold on, so that turns the hold on to the plot window. So when I do another plot command, it won't erase what I have already. It'll just add to it. So let me just say hold on. Let's say plot T and Y2. Oh, and let's tell it to be red. So I can give it another command with a little R character in there, and that'll make it red. So aha, there's that other one. Isn't that nice? I like it. I just put it right in there. So there's the Y2 curve. And of course I can click on it, I hope. Yes, and make it thick just like the other ones. Sweet, right? Another thing you might want to do in your plot window is to put a legend. And I think you can do it with this button right here, but I like to do this one manually. So I can say legend, and I can put those plots in order. So the first one was the S, and that really is just a sine function. So let me just give it the name sine. And the second one was that straight line. That was a Taylor series expansion for the sine function about some point 2.2, I think it was. But I'm going to call that Taylor 1. And the third one was a second order Taylor expansion, so I'm going to call that Taylor 2. Taylor 2. So I have names for these plots, and I'll click that, and let's look at our plot window, see if that came up. Yes, check it out. So it has those three curves on there, blue, green, and red, and it's labeled them sine, Taylor 1, and Taylor 2. And I can relocate these things if I want. I think I can. Let's click it. And if I want that legend to be over here, I just sort of click in the upper left-hand corner of this window down there. And quite nicely it moves over. In fact, I can bring it outside the plot window if I wanted to. I kind of like it inside because it fits. But there's that. Now we have this beautiful plot. In the next video, I'm going to show you how to save this plot so that you can insert it or embed it in a document in a way that looks sharp. Okay, you'll definitely want to see that video too to go on. But that's the end of part 1.